Okay, hello and welcome, dear participants, to our session today entitled Wastewater and Flow Regime Water for the Environment and Water Reserve. You're enjoying a course offered thanks to the support of the GEF CReW Plus project, whose purpose is to provide knowledge and a space for the co creation of water and sanitation solutions in the wider Caribbean region. The GEF CReW Plus is a collaborative project funded by the Global Environment Facility, co implemented by the Inter American Development Bank and the United Nations Environment Program in 18 countries in the wider Caribbean region. GEF CReW Plus project is being executed on behalf of the IDB by the German Agency for International Cooperation and the Organization of American States on behalf of the United Nations Environment Program by the Secretariat of the Cartagena Convention. The GEF CReW Plus project offers innovative, nature-based solutions to mitigate the effects of untreated wastewater on the environment and the public health. The Central American Institute for Public Administration, ICAP, is a institution, sorry, is the institution that specializes in the education and training of the human resource at the local, national, and regional level. So it's a pleasure for us to be the institution in charge of facilitating this learning space. The institution was created in 1954 within the United Nations with the support of the Economic Commission for Latin America and the Caribbean, within the Secretariat, General Secretariat of the Central America Integration System. My name is Maria Paula Rojas, and I'm the project assistant. I will be the person who will accompany the teacher this morning. Before we begin, this session will be recorded and uploaded to the ICAP Virtual Campus website. If you do not wish to be recorded, I kindly request that you indicate this via the meeting chat. The training provided in the framework of this academic program will be divided into modules. These sessions belong to Module 3, in which we will address elements of the importance of the hydrological regime, the conservation of natural ecological flows, and the importance of the hydrological regime. Um, in addition, we remind you that upon active participation during the synchronous session and completion of the evaluation activities hosted in the ICAP Virtual Campus, you can opt for a certificate of achievement issued by ICAP with regional recognitions. I now introduce the facilitator of the module. The facilitator with us today is Ignacio González Mora, a biologist with further studies specializing in applied statistics at the Institute for Research in Applied Mathematics and Systems. In 2005, he joined the technical team of the World Wildlife Fund in Mexico. He's part of the coordination of the Mexican Watershed Network in 2011. He's a founding member of the Central and the American Continental Network of Participatory Community Monitoring, whose initiative took shape in 2021 under the leadership of the National Alliance of Rivers and Watersheds of Costa Rica. I will give the floor to Ignacio to begin the module 3.
Thanks a lot, Maria Paula. And hi, everyone. I'm very excited to share some thoughts and insights on the health of rivers, lakes, and freshwater systems, all is related with hydrological regime, environmental flows, and water reserves. All these items related to conserve healthy freshwater systems to benefit with the environmental services, and all we have to do better efforts in integrated water resource management, thinking of environmental flow and water reserves. Um, I'm going to turn off my camera, and I'm going to share my screen in order to start the presentation. Can you see the presentation? Hello, hello.
Yes, it's off.
Thank you very much. Okay, well, Maripola has already given us the information on the financiers, implementers, and executors, and I want to particularly thank ICAP for all the support and facilities given for the competition of this model and this program. Well, the main aspect I am going to tell in this module 3, is the wastewater and flow regime, water for environment, and water reserve, as you have heard. Okay, we are going to see the content of the module 3 and describe the topics that we will be addressing during these sessions. First of all, status of aquatic ecosystem and their biodiversity is the relationship with the freshwater biodiversity and the status of aquatic ecosystem that is very important as part of a set of indicators of the health of our ecosystems. Then we pass to impacts of climate change on the hydrological dynamics of our basins and relations with water stress. We review the basis of hydrological regime as the key to understanding water management and the condition of use. We are to see the environmental flow concept, the importance into the integrated water resource management approach. We reviewed the methodologies for environmental flow determination, some lessons learned. And in this part, finally, we review the relationship between environmental flows, e-flows, and treatment of wastewater. The water reserves is a mechanism, a legal mechanism found in Mexico to protect the environmental water allocation. And we have some ideas and reflection about that. And then finally, in this module, we see summary of cases in Mexico, Central America, in terms of environmental flows and water reserves implementation and some governance challenge. Well, uh, to finish our model, we have a section with questions, comments, or final reflections. Well, in our first item, status of aquatic ecosystem and their biodiversity, we present three recently issued reports that tell us about the freshwater biodiversity and the human activity. First of all, we see the Living Planet Report 2020. It's a biannual report issued by WWF. And in this report, we can find that the freshwater ecosystem show a tendency to a higher proportion of species threatened with extinction. The trend is greater in aquatic or freshwater ecosystem than in terrestrial or marine ones, globally speaking. More than 3,400 population assessed by the Living Planet Freshwater Index have declined by an average of 84%, equivalent to 4% per year since 1970 year. Most of these losses occur among amphibians, reptiles, and freshwater fish in all the regions of the planet. Of course, amphibians are sensitive indicators of watershed deterioration because they spend life stage in fresh water and on land. And of course, fish are the most sensitive species to indicate the deterioration and contamination in aquatic systems. And that is, it's not surprising, this result. But in terms of the region assessed by the index, um, we have I especially mentioned to Latin American, Caribbean, LAC or LAC region. Our region is the most threatened region in the world in terms of losses or deterioration of population of freshwater species. It is a real a reality. Well, in this report, we see the three major threats of freshwater systems in our region are water overextraction, climate change in terms of uncertainty about precipitation patterns, and also the hydropower projects. There's hydroelectric projects designed and built on sensitive side or sensitive stretch of the river are a real threat to the functioning of our range. And all these three threats are impact mainly the fishes. As you can see in these three main factors of deterioration, all of these are related or closely related to water quantity. But in this model, we're going to talk about the other very important aspect that is water quality. Well, I mentioned the importance of fish in terms of biodiversity impacts related with the human activities in our freshwater systems, and a group of 15 international organizations issued a report in 2020 years called World's Forgotten Fishes. This report is specific with freshwater fishes as the forgotten species, since much of attention has been given internationally to marine fishes due to their economic importance. But we are forgetting the freshwater fish that also sustain local economies and are the essential source of protein in many of our countries. And the report, the results show us that one-third of freshwater fish species are threatened with extinction. 80 species have already been declared extinct. The principal group threatened is the migratory fish population, which show decline by 76% since 1970 year. The health of ecosystem is vital to maintain the biodiversity of fishes, and in this context, around 35% of wetlands have been lost in the last 50 years. Well, many of these fish live in the wetlands. It's important to strengthen conservation efforts in the system because several of our countries in the LAC region are signatory parties of the Ramsar Convention, and we have to improve better efforts to conserve, of course, the wetlands and their biodiversity. This is the second report. Megafish, the big fishes and freshwater ecosystem have declined by a catastrophic 94%. It's a very threatened group of freshwater fishes. And bad news, Mexico presents 12 species in this list of 80 disappeared species. You can see in the graph, the pie graph, the country with the most number, the major figure of species in extinction is United States with 19, following Filipinas with 15 and Mexico with 12. In addition to all these results, the IUCN has declared that 10 more species have been declared extinct in the wild, and 115 are classified as critically endangered and possibly extinct. The fishes are shallows. I shout out that we have problems in our system. Humans are not properly manage the freshwater ecosystem in a better way to conserve the integrality and functionality of our freshwater systems. The third report is the Emergency Recovery Plan, published in 2020, and it's a document with an urgent call to implement an emergency recovery plan for freshwater biodiversity. The threats for the biodiversity are often synergics. In these terms, current planning and interactive priority action is necessary to address such treatments. We need to avoid the sectorization or divide or share the efforts to face of the threats of our the threats of freshwater biodiversity. We have a holistic thinking and holistic approach in terms of diminishing this synergistic interaction and deterioration of our freshwater ecosystem. This report was developed by scientists and freshwater experts around the world, and this practical science-based plan incorporates 6 pillars, each of which has been implemented in different parts of the world. And the urgent call is implement the 6 pillars in all the countries. Well, the main message of this report is urgent need to bend the curve of freshwater biodiversity loss that needs to be reflected in the post-2020 biodiversity collection. We have in the decade of restoration, we have a revision of CBD agreements and how to implement and cover the SDGs, and it's necessary to implement or accelerate the implementation of the 6 pillars that this emergency recovery plan established. Well, that's the 6 pillars. The first one is in terms of river flows naturally. It means we must accelerate implementation on environmental flows. 2, we must improve water quality. 3, protect and restore critical habitats. 4, end overfishing and unsustainable sand mining. That's an item frequently forgotten in the integrated water resource management, but it's very important. 5, prevent and control the invasion of non-native species. And 6, protect free rivers and remove obsolete dams. It means protect and restore freshwater connectivity. The items we are reviewing in this module 3 are concerned and related with the pillar 1, rivers flow naturally, 2, improve water quality, and 6, protect and restore freshwater connectivity. In terms to get or achieve better efforts to conserve and maintain the environmental services that our freshwater ecosystem provides us. Well, in terms of impacts of climate change on the hydrological dynamics, I want to mention that the global warming has impact in our climate, of course, but particularly in temperature and rainfall patterns. And of course, these two factors affect the pattern of flow and storage of water resources in basins in the surface and the aquifers and groundwater. A third aspect to be considered in water management, in addition to quantity and quality, is temporality or opportunity of the water present in the territories and that available to all. So in our model is I put emphasis in these three factors: quantity, quality, and temporality, in terms to reduce the water stress and improve the health of our freshwater ecosystems. Some studies show us the precipitation in terms of average annual precipitation are in diminishing. The slope is negative, and this is analysis. These impacts of precipitation, of course, are related with the runoff. You can see this line in orange is the curve line to describe in the time what is the tendency of the runoff in our rivers, and all this is related with water availability. You can see this square. Let me use the pointer. So in this graph, we can see the dispersion about the data between the assessed runoff and real runoff, and in this recent years, the dispersion of the data is more. This means that we have uncertainty in terms of water availability, runoff, and precipitation. In summary, impacts of global warming are mainly in the rain and temperatures that impact the flows and storage and surface and the groundwater, and then in water stress, because availability of water over time is also compromised. The purpose are to mitigate the water stress. Actions are required that allow the adequate quantity, quality, and timing of water to supplies user. An important change is required here because water services are provided constantly in the population, regardless of the hydrological situation and its natural variability. We can see this graph is an graph with the flows and time, and we can see the water in our rivers show us variability. In some months, we have minor flows, and in the rainfall period, we have extreme values of flows. The security of this use and distribution of water lies in the understanding of variability of water bodies over time, and thus adjusting the management that is done to meet the needs of human populations. It's so important in terms of integrated water resource management and watershed approach to have in mind the time, the variability of our water system, freshwater systems, to do the better management in terms of this variation. To see and analyze this variability, we are going to review some basic concepts of hydrological regime as the key to understanding water management and competition of uses. Well, we are put emphasis in variability over time. Knowing the nature of water as it occurs in basin aquifers is important to make it through the water resource management. It's necessary to measure the intra and interannual variation of flows. The flow variation defines the hydrological regime of a river. That's the importance. Hydrographs, as you can see in the previous slide, are the graphical representation of surface runoff, the flow over time, and help us to understand the variation. Ideal water management should be done following the natural regime. It's a regime. It's a very important insight in this module. Now we are seeing an hydrograph, and we can see the intra and interannual variation. All this group of data represents a specific year, but we can see some groups of this pattern is representing for long periods, more than 1 year. And that's important to see, to keep in mind this variation interannual in terms of understand what is the, the variation and what is the use we can benefit of our population, human populations, and sustainable manner. Well, in relation with this idea to have focus on the time variability, we have faced the conflicts among users. This is one contribution. Now in the regime and under a hydrological cycle approach, the hydrological regime conflicts and demands for use through the year and between years can be understood and described. A management plan by reducing competition between use over time is then necessary. In terms of the experience developing in Mexico in terms of environmental water allocations, e-flows, and water reserves, we are proposing a paradigm change in terms of the users of water. In the graph, pie graph on the left, we can the water, all the water, and all the users are taking a part of this volume. This situation um, permits in our country permitted the overextraction on the time. We propose then we need to consider the environmental flow regime at the center of management plan, conserve this volume, and then use in other different uses the rest of water. Thinking, of course, in the variation on the time. This is a very important change. Well, we are avoiding the environmental flows. First of all, I want to mention that in the most recent international revision was revised in the International River Symposium and Ecological Flow Conference in Brisbane in 1970. And it states that environmental flows describe the quantity, timing, and quality of freshwater flows and levels necessary to sustain aquatic ecosystem, which in turn support human cultures, economies, sustainable livelihoods, and well-being. That's a very important definition because it integrates the flows, quantity, timing, and quality of flows. It means rivers and levels. It means lakes and dams, including wetlands. Yeah, we are integrate the integration of Atlantic and Lotic system. But you can see all this the effort to have environmental flows with three aspects, quantity, timing, and quality, is in benefit of human cultures, economies, livelihoods, and well-being. The, the main benefit to conserve our freshwater ecosystem through environmental flows is the human well-being. Well, as I mentioned in this definition, both Lotic and lentic systems are integrated and the social spheres, cultural, livelihood, well-being are made explicit as goals of good water management. That is our recent thinking about eco-hydrology, about rivers and lake well management and with all benefits devoted to the human societies. Well, the e-flows, the environmental flows, allows integrating the concept of aquatic systems, hydrological regime, hydrosocial cycle, integrated water resource management, quantity, quality, opportunity of water, conservation of ecosystem services, and finally, benefits to the human population. The flows transfer their legal implementation as water reserve from the environment. And these water reserves from the environment are recognized as a measure of adaptation to climate change. Likewise, it's easier to establish a classification of relevant hydrological basins for water management due to their environmental importance and to define specific goals for conservation or recovery of flows and water quality. In the case of Mexico, develop all these analysis studies nationwide, permit us specific goals for conservation or recovery of flows, water quality, and classify all our watersheds in all the country in 4 different types from A to D. A is related with a low pressure of use and high or very high ecological importance of its watershed basin. And the classification D is related with basic with very high pressure of use and low ecological importance. All these permit us establish using criteria based on ecological importance and pressure of use, and create a matrix and cartography that shows the classification of the basins, as you can see in the left and in the right. This before it was possible with the participation on some actors from the government, on academic institutions, and non-governmental organizations, all discussing together for several years. We can agree, we can achieve the consensus to establish this classification, these goals in terms of environmental flows. I want to show us a video, 3 videos with animation, graphic animation, in terms of have a visual idea that what are the rivers, the alive rivers, alive with environmental flows, healthy rivers, and rivers with some infrastructure or the impact of the cities. Please look at this animation and think of what is happening. Again, that's a natural river, a healthy river, and it's possible to see the 4 dimension of connectivity, the longitudinal, as the runoff follows, the flood and horizontal, or flood and horizontal connectivity, vertical connectivity in terms of water infiltrations, the surface water to groundwater, and the 4th dimension is the time, temporality. Again, the time. That's all benefits for the basin, including agricultural activities, of course. Now we are seeing we're going to see the rivers with dams, rivers with infrastructure. You could see the impacts on the fishes in terms of floods, in terms of runoff, and in terms of infiltration. We have a dam. And if you remember, one of the three main threats in Lake region in terms of the deterioration of freshwater ecosystems is the hydroelectrical dams. Well, what happened with rivers and cities? You can see the impact in terms of extraction on the river, but also in the aquifers. And the activities related to agriculture is impacted also. And imagine for a moment if also the city dumps its solid pollutant and wastewater into the river. There is a negative synergy in terms of pollution and with important effects on the river. That is our main concerns in terms of environmental flows and the health of freshwater systems to keep the environmental services and benefits to our population, human populations. Well, we are talking about the methodologies related with environmental flow determination in terms only of a lesson learned in Mexico. Well, in Mexico, we discussed for many years, 7 years, which will be the best method. And all this time, we are consulting the Australian teams, line of thinking, the South Africa line of thinking in terms of environmental flows. This discussion were for a long, long time. Finally, in 2012, it was possible to agree on a standard and a norm among the technical group of 10 actors, and the standard, the norm was published. That's the code for our standard in Mexico. In this standard, we pass that discussion about methodology in terms of declared that any methodology is valid if it understands the ecological meaning of each component of natural regime, and proposals are generated for its conservation or total or partial restoration following two main scientific principles. One, the paradigm of natural hydrological regime, and two, the gradient of the biological condition. Then there is no magic methodology or unique methodology with the solution for all our basin and of our purposes of integrated water resource management. We can use different methodology for different purpose if we take into account the paradigm of natural hydrological regime and the gradient of the biological conditions. In the norm, we establish four main groups of methodologies. First of all, hydrological methodologies for a basic level of analysis for water planning or for areas of low conflict over water use. That methodology only used data, hydrological data, historic collection of data, and the analysis carried out in the room. We have hydrological methodology with analysis of ordinary and fluid regimes. And this methodology is applied in basins where the resulting ecological flow regime represents a conflict due to infrastructure operation. In terms of dams, in terms of some infrastructure that modify the flow, the natural flow regime, we use this kind of methods. The third group is hydrobiological or habitat simulation methodologies to project the physical habitat in its changes depending on the flow. Thus, it quantifies the habitat preference of the species. If we have in mind or the problem is one species inhabit the freshwater ecosystem, we can use these hydrobiological methodologies. And finally, the holistic methodologies allow the evaluation of conservation of risk scenarios of different water resource management alternatives. They are also recommended for cases where it's required to detail a flow proposal given the complexity, difficulty, or social or environmental conflicts. Environmental and social interdisciplinary teams are requiring this methodology. This is the most rich with more participation of different experts, academic institutions, to compile the required information to give this holistic approach better information and take decision by consensus. These main three e-flow methodologies have different requirements for teams or human resources or material resources and financial resources. Hydrological are with lesser requirements in terms of these requirements, and holistics are more demanding in terms of resources, human resources, material, and financial resources. But you can use depending of if you are doing water planning or conservation risk scenarios in terms of complexity, social, environmental conflict. Well, we're going to reflect about the e-flows and treatment of wastewater. It's important to reflect on the relationship between the quality of wastewater discharges into the environment and the impact of good treatment on the health of the ecosystem. Water bodies are a fundamental part of our ecosystems and a source of supply for population received across wastewater. The quality and timing of the discharge of these have an impact of natural system, and in this way impact two of the three main aspects of environmental flows. As you remember, the three main aspects are quantity, quality, and timing. In terms of wastewater, of course, we have impacts with quality and timing directly, but in some cases also in terms of quantity. In some of our cities, in the period where the rainfall is scarce, the river flows just with wastewater, and it's just a real aspect. The contribution on effective and efficient water sanitation is essential to maintain the flows, the integrity of aquatic ecosystem, and therefore their health, as well as the quality of ecosystem services related to hydrology. Well, in holistic methods, water quality specialists are always summoned or called to analyze which variables and at which levels can support the ecological and social processes associated with the aquatic systems. In case of Mexico, studies on classification of receiving bodies and their corresponding declaration of classification water bodies, it's an area of opportunity to establish goals in terms of the what's the wastewater quality needed in certain specific basin. The intention is aimed at maintain aquatic ecosystem services, especially support and regulation services, because thanks to them, organic logs and some pollutants from water bodies can be assimilated. The role of treatment systems is relevant to achieve water quality in a basin, a water body, or a section of it. It's important to mention that in holistic methods include water quality studies from physicochemical and biological perspectives. The presence or tolerance of fish species and benthic macroinvertebrates are included in the studies as indicator of water quality. We have the opportunity to have both perspectives. Well, in terms of water reserves, I want to summarize the case of Mexico. As I mentioned before, in case of Mexico, the water reserves have the intention as a legal mechanism to protect the environmental flows determined for all the people or the users in the basin. Is this case in terms of guarantee the legal compliance, the e-flows in the basin. This initiative unleashed an innovative national public policy for Mexico starting in 2012 that culminated in 13 decrees by the federal executive power to reserve annual flows in 295 hydrological basins in 2018 year. And in Mexico, we have near to 600 basins. In this case, the water reserve was decreased in 45% of our hydrological basins. The protected annual volume means 55% of the country's surface water and benefits the connectivity, resilience, and water needs for 82 protected natural areas and 64 Ramsar sites. That's a very important contribution to preserve our natural capital in Mexico, because all the public policy related to protected natural areas are integrated now with public policy related to water and water reserves. All these legal mechanisms are contributing to preserve these important natural areas for the country. In the map, we can see the hydrological basins decreased in dark blue. We are six main hydrological basins, which are concerned with academic and non-governmental organizations organized to discuss and improve the implementation of water reserves in the watersheds. And all these basins have been decorated in blue. In yellow, all the other basins with e-flow studies, and in the process for the water reserves decrease. We began with San Pedro Mezquital River Basin in 2040. It was our first decree as this innovative water public policy, and we have 13 decrees that I mentioned. And this effort has been shared with other offices in WWF organization, with colleagues from the governmental institutions in other countries. And now in LAC region, there is a similar initiative to protect ecological flows and transform them into water reserve from the environment in accordance with the experience, advance, and regulations of each country. This is very important. All these efforts have been done in terms of what is the legal framework on each country. Currently, the initiative participates Bolivia, Colombia, Ecuador, Guatemala, Honduras, y Peru. It's very good news to mention to you that two countries on the Central American region has been involved in this regional initiative. And that initiative is part of all freshwater practice effort to preserve the freshwater ecosystems. At the moment, WWF Freshwater Practice has 9 international initiatives. One of them is water reserves. And you can see in the map, this is the country in all the region. But it's important to mention that these 6 countries have important efforts and show interesting advances in terms of regulation studies first, regulations, and governance contributions. Well, we have a view of some cases in Mexico and Central America, and some of the governance challenges have been discussed during these sessions. But I would like to tell you that Mexico a very important watershed with water reserves. This is for the Usumacinta River. The Usumacinta River is one of the largest river basins in the country. In this watershed, the water reserve volumes is around 90% of the average annual runoff, and that was decreased. That's very important to mention and have and keep in mind, because environmental flow isn't a minimum. It's not a minimum value of runoff in a river or in a lake. It's not minimum. It's a limit among the different types of watershed classification. I'm going to go this this picture to explain a little more in terms of ecological flows, sea flows. No, no have not the meaning of just a minimum value. Each of these types of hydrological basins, A, B, C, D, have limits, and in order of that ecological importance of pressure of use, you can establish these limits. You, for one basin, you can determine as an analytic exercise what are the limits for the classification D or C or B or A. And in terms of water councils or basin councils, the entity of governance, the water governance, we can discuss in which classification our basin is and what kind of efforts we are going to do to improve the classification, for example, the D to C, C to B, or B to A. For all this classification, we have limits, no minimum. Well, in this sense, this very important for biodiversity watershed in Usumacinta River. The decree is established the 90% of average annual runoff as water reserves for ecological protection. The contribution to hydrological connectivity are relevant in this basin of high biological diversity, and the proposal for water reserve was presented, discussed, and approved by the respective basin council. In our country, this is the entity for the water governance with the participation of actors and water users and authorities in terms of federal, state, on municipal level. And in this space, people present the initiatives, projects that are discussed and approved, and we are monitoring the compliance of these projects or initiatives approved. It's very important, but we need to improve the level of discussion and participation in that basin council. And the Basin Council, in coordination with Monitoring Network of Water Reserves, in Spanish, Red de Monitoreo de Reservas de Agua, Red Mora, A monitoring system and a management plan must be designed and implemented towards the regulation of the basin. In Mexico, we have another specific public policy that improve the regulation get by the water reserves, and this one, other regulation is uh, uh, the it's like a normative document that complete the regulation in the other users more than environmental. Yes, with agriculture, industrial services, aquaculture, etc. We had the regulamentation for the basin. As I have mentioned, this is a very important watershed. That's a binational watershed. This is Usumacinta and Grijalva, both of two born in Guatemala, and its flow is in order to this amount of water. It's huge, it's near to 40% of the annual runoff in all Mexico. The basin, but mainly Usumacinta, have high biodiversity, rather biodiversity in Mexico and Mesoamerica, have or integrate 18 natural protected areas, and the environmental objectives or type of watershed type is type A. It's very important. It's the most important watersheds in our country. The watershed was studied in 3 levels: the high level or upper part of the basin, middle part, and lower part of the basin. And you can see the water reserves decree the values determined by e-flows studies, and you can see the average annual runoff that was decreed. In the upper part, 99% of the annual runoff, Catasaja, middle part, 90%, and Tres Brazos in lower part is 90. As you can see, no minimum. A limit for a very important, very biodiverse watershed. Well, we are talking about the case of Guatemala. For this country, we have a national strategic analysis to classify the basins, and a territorial approach was used, and then the water management was proposal. In terms of define, first of all, the priority in terms of watershed and its benefits as a territory. The national government is committed to the water reserves, and this committed is published in the government agreement number 19 in 2021. And of course, it's an international example to overcome the legal vacuum around the water, because Guatemala is lacking in terms of water law, national water law. This government agreement has the principles to integrate and organize the participation of different institutions in terms of get the better water management public policy. Efforts have been made to strengthen technical capacities. Some workshops develop and implement technical instruments, conserve and protect water reserves, and of course, exchange of experience between Mexico, between Honduras, and other countries that are involved in the initiative of water reserves in LAC region. Well, all this discussion carried out to get a methodology and primarily preliminary map of strategic water reserves, validated and discussed with representatives of government institutions related with water in Guatemala. Ministerio de Ambiente y Recursos Naturales, Instituto Nacional de Sismología, Vulcanología, Meteorología e Hidrología, Instituto Nacional de Bosques, Consejo Nacional de Áreas Protegidas e Instituto Geográfico Nacional. Experts and people representative of this institution have participated in all these efforts, workshops, discussions, and then we have important results and advance in this country. In the agreement, the institution state its recognition of the importance of this scientific contribution made by WWF Mesoamerica to establish and prioritize strategic water reserves of the country, which will facilitate decision-making for integrated water management, water security, conservation of natural resources, and biodiversity, as well as adaptation to climate change. The commitment, including working together to strengthen the regulatory framework related to the strategic water reserve for Guatemala, and jointly developing proposals to manage financial resources in order to achieve the objectives and purposes of the water reserves. Then, as you can see, Guatemala is doing all the efforts to protect the main water masses, the main watersheds in the country in terms to achieve the water reserves for the country. What are the main results? They establish hydrological criteria, taking into account hydrological analysis, forest analysis, territorial analysis in terms of basins, priorities to catchment water, recharge of water, regulation of soil, erosion. As conservation criteria, we establish where is the Ramsar sites, where is the natural protected areas, what is the biodiversity, regulation of water, connectivity, ecosystem connectivity, and with this criteria, we discuss and issued a first map, a preliminary map in terms of strategic basin for water reserves. As I mentioned, as a result of national exercises, to raise the importance of priority of basins at national level. And this is the case of Guatemala, and we are so excited to share with you these important results. What about Honduras? In Honduras, there is a comprehensive management policy for water resource, which establishes that need to have special regulation. They establish a strategic line to get exploration and use of groundwater, water reserves, ecological fund, among others. And this is the discussion at the moment. They are aligned with the guiding principle of water sustainability. Yet the reserves have a territorial focus in the same case of Guatemala rather than water management, but protect recharge areas and population supplies. In the mind of Guatemala's Honduras, of course, is the goal to satisfy the population supplies with water in quantity and quality. Well, this water public policy is called the proposal for a special regulation for the water recharge reserve zones and water producers had been achieved in 2021. Actions are established to provide greater legal certainty and protection of the water source of Honduras to guarantee the human right to water. It's a moment to mention, of course, the studies for water the water reserve, keep in mind the well-being and the human rights to water. Mexico, of course, have in the legal um, national framework the idea to guarantee the human right to water also. In this term, the water reserves can contribute to this main objective of complete or guarantee the human right to, to water. And it's necessary to make the entire Honduran population aware of the territorial dimensions that cover around governance. And it's important to highlight the need to improve instruments such as this, which allow the guidelines of the General Water Law to be regulated in a detailed manner, as well as this recently approved regulation. Well, in terms of Central American region, I would, I would like to put the attention in the Estrategia Regional Ambiental Marco, the Regional Environmental Strategy Framework. This strategy, regional strategy, is published by 2021 to 2025 year. And I want to remark also is a very good example of international integration in which the strategic line integral water management resource and the strategic action 322 that says implement a regional strategy to protect and restore the water ecosystems of the country, including water reserve, based on the promotion for a new water culture with a focus from the basin to the sea, technology and economic evaluation of water. All this statement is related to the topics reviewed in this module 3. This strategic action includes water reserves for environmental and ecological flows, of course, and give the platform for all the signing countries to explore and develop these important pillars of the international club, international code about the emergency plan that we review in the initial items of this module. Efficient wastewater treatment system and their positive example can be lead a paradigm shift in basins to reverse the regional trend of deterioration of freshwater ecosystems. Well, it's so important, this integration, collaboration among the countries, and is, of course, I said, a very good international example. Well, the regional strategy have 5 strategic lines. One of these is environmental quality. Second is seas and biodiversity. Third one is related to integrated water resource management. Four is forest and sustainable landscapes. And finally, climate change and its risk integrated management. All these are related. I have read this important document. All that's integrated, and that's a very comprehensive framework to integrate the environmental aspects for the Central American region. The strategy also had 5 transversal axes. One of these is capacity building and knowledge management. In these terms, with the water reserves initiatives in LAC region, we have participated with people from Guatemala and Honduras in several workshops, several discussions, and in technical assistance to have and share the better knowledge available in terms of hydrological regimes, ecological flows, water reserves, and have the better information. The other transversal axis is the legal and regulatory framework. We have, in the case of Guatemala and Honduras, the results, the preliminary results, but the big effort to achieve the integration and collaboration between the governance instance or dependence institutions that are related with water. And in case of having no national water law, how to put acts, some public policy agreements to establish this regulatory framework in terms of improve the health of our freshwater systems. Dialogue and intersectoral coordination, of course, is carried out in Guatemala and Honduras in terms of have a better understanding about the complexity of water management, and the effort have very excited results. Research and development of technologies. In this case, the environmental field has new approaches, new data management platforms, develop of new GIS systems, and incorporate some data from the water measurement networks in the country, and new approaches in terms of scenarios of modulation to run mathematical models or climate change model to put in the desk, discussion desk, the future scenario in terms of climate change. And also have a gender and intercultural approach, terms that all the new regulations, of course, in terms of water items, have this perspective of gender and intercultural approach in terms of we live in countries with different indigenous population and local communities, and we have to transform that regulations in terms or meanings that promote the participation, collaboration, and the governance water instances of all our populations, all our cultures that live in our countries. Well, as examples of the intention of this regional strategic in terms of environmental as a framework, we can see as example 2 indicators in this framework. One of these is percentage of water ecosystem at priority water bodies in the region with good quality water mass. In these terms, the basins analyzed and the basins with determination of environmental flow could help us to prioritize the water bodies, to put on the table the goals of good quality water masses, and then we can have a list or evaluation how in our country are advanced to implement and contribute the water ecosystems with water quality masses and some or contribute to the percentage, the regional percentage. The other one is the percentage of national or regional actions implemented within the strategy for the protection and restoration of water ecosystem in the region. In these terms, as I have mentioned, Guatemala and Honduras are our leads in terms of environmental flows, water resources, but it's so exciting to think of new countries, new people, new institutions in Central American and Caribbean region is involving and is participating in this initiative on terms of what the technical basis, that's a scientific basis based on environmental flows. And then we can talk about the freshwater ecosystems with health, with integrity, with benefits and well-being for our population in this region, Central American and Caribbean region. In this part of questions, comment, and final reflection, I would like to take some slides I present you in this module. I take some main ideas. I'm going to go at the beginning of presentation. Okay. Well, keep in mind that our region, Latin America and Caribbean, had the most of the losses of populations of amphibians, reptiles, and freshwater fishes, globally speaking. The populations in freshwater ecosystem have a living planet freshwater index in average of 80%, minus 80%, and that's the ecosystem more threatened in our planet. This is the figure and the tendency of the index living planet report 2020.
Thank you.
See?
We have a few questions in the chat box.
Okay, please.
I'm gonna read it. I'm gonna read the first question to you.
Okay, please.
In your opinion, it should be desirable to promote zero discharge from industry and cities to preserve the quality of environmental flows, considering that urban use takes about 20% and industry takes 10% of the water. That is the first question.
Okay, well, it's important to keep in mind this concept of zero discharge, or zero, no wastewater discharge. We can think about the quality of this water, this wastewater. It was the capacity or environmental services that our river can provide us. It's it's ideal to have a zero discharge, but we in our countries we must thinking of what is car discharge and in which level of different variables or parameters are discharging and what is the capacity of our river to assimilate this charge. That is mainly the option, the pragmatic option that avoid all the discharge. And we can use as I mentioned in Mexico, we have the studies, specific studies to classify the water bodies that receive the wastewater. And this kind of studies is very useful to keep or to achieve these wastewater quality goals. On the other hand, the ecological flows, the environmental flows could help us to establish water quality goals in terms the what's the watershed we are studying, in terms of a group or a team or a water quality specialist, we have by consensus established this goal. In this case, if we study our basin with a holistic method, we can establish this water water quality goals or goals for the wastewater quality in terms of keep our rivers in health. That's all.
Okay, thank you. The second question that we have is in terms of quality, how to guarantee the required quality to protect, preserve, or even improve flows quality. What about agriculture? In Mexico, there is no treatment for agricultural lixiviates, and the agrochemical lixiviates get into rivers and aquifers.
Yes, it's a good question. It's a challenge because the wastewater treatment in terms of pipes at the end of the pipe of a industry, a city, it's uh, it's easier to it's easier with some smiles. It's easier to treat this kind of wastewater discharge. But in terms of the agriculture, manure, and some activities, productive activities that are very difficult to control, to conduct in a pipe, the wastewater is so difficult. We need to have another approaches in terms of integrated watershed management and taking into account another agricultural practice. In the watershed I work in Mexico, in the state of Oaxaca, south of Mexico, in terms of how to stop the agricultural pollution, we are changing to agroecological practices. It's in this case is not a challenge for wastewater treatment. It's a challenge for the activities in terms of how to produce the food in terms of vegetables, or in terms of meat, how to we are producing these very important satisfactors, and we change the productive way of work. And then, and for this reason, it's very important to have the meaning of integrated water resource management with watershed approach, because we need to change or improve our practices in terms of how to use the forest, how to use the soil, how to use the water and biodiversity to have a minus impact to preserve our freshwater ecosystems and have the well-being of all people want. Thanks.
Thank you, Mr. Ignacio. The last question that we have is even if we can try to protect the quantity, how to assure the protection of the alive rivers in terms of quantity and quality?
Yes, please, could you read me again?
Yeah, sure. Even if we can try to protect the quantity of flows of the rivers, how to assure the protection of the alive rivers in terms of quantity and quality?
Well, uh, one of the main tools we review in this module is, of course, all the science in terms of environmental flows. Because in this approach, we have quantity, quality, and timing. Remember the three main factors. That's another main insight of this module. We have in mind And keep in mind these three aspects. Again, quantity, quality, and time. Well, we need to study our basin, our rivers, or our lakes, wetlands, to have in the time what's the conditions and what's the relations between the quantity of water in terms in quantity as a flow, in quantity in water depth, in terms of water velocity, of course, in these attributes of the water quantity, we need to measure what these variables are affecting the natural populations, the biodiversity. And with this, we have a very precise diagnosis about the quantity. Of course, the social and socioeconomical activities have been studied and analyzed. When is necessary, the water for agriculture, for aquaculture, for tourism, natural ecotourism. It's important to have in mind this and all this in terms of quantity. But we also relate it with different variables or parameters of water quality in terms of not only is quantity, we need to have what is the quality for direct contact for human beings, what is the level also limited for a specific fish population, what specific values of what parameters for keep in productive way an aquaculture project, etc. So this is the second aspect to analyze. All this related with time. That's I want to invite all of you to read more about the hydrology related to the environmental flows, the flows, and how to many countries are implementing that technical and scientific knowledge in the public policy, in the regulation framework to guarantee that these goals established in terms of quantity, quality, and timing, the people are respect for them and contributing to get the quantity quality goals. That's a complexity, but this is the way we are working in this initiative in the Latin American Caribbean region. That's all.
Thank you, Mr. Ignacio. We have a lot of participation today. I have a few more questions.
Okay.
Do you think the residual waters that are thrown into the sea are causing eutrophy, eutrophication like in Mexico coast?
Yes, of course. It's so important the contribution of the process in the continent, epicontinental systems, to the coastal and marine ecosystem. In a natural sense, in a natural regime of the river, it's very important the water, the quantity of water, nutrients, and sediments that the river carries in through the basin until the sea. For all the coastal processes are so important. If one of these fall or is or have a perturbation, by human activities without impacts in coastal zone. And in Mexico, we have a case in Rio Santiago River. One institution decided to build a dam for electric generation, and the dam capture all the sediment, and these sediments are no longer passed to the coast. The amount of the river in the last part, in contact with the sea, have in average 20 meters wide. 20 meters wide. With the dam, actually, with several years of this dam working, the most wide of this river at the moment to make contact with the sea have 2 kilometers. And the impact is all the estuarine systems in the coastal zone. The estuarine system, it means the mixture in salt water and fresh water. There are no more in estuarine condition. Now it's a salt condition. And all these examples of bad management of the watersheds and the rivers have important impacts in the coastal zone. And on the other hand, of course, if in our upper part or middle part of the basin, we have traditional agriculture with pesticides and chemicals. All these substances are going to travel to the river and contaminate the coastal zones. And we see in the videos the interaction in 4 dimensions of connectivity. I mentioned the longitudinal connectivity as the river flows, the transversal connectivity in terms of flow when the river flowed and flow the adjacent terrestrial ecosystems. The third one was the vertical connectivity, and if a river carried pollutant charge, a lot of these substances are going to infiltrate into the soil and get the aquifers and contaminate this groundwater. Then this is in terms of the importance of well management of our watersheds, of our hydrological regime, also help with the e-flows approach, and then have a better practices in terms of forest, soil, water, and biodiversity to avoid the deleterious impact. Thanks.
Thank you. We have the last questions. We have 2 more questions. The first one is in establishing water quality goals for the watershed, how do you account for non-point sources of pollution?
Yes. Please, Maria Paula, read me again the question.
Okay, I'm going to read that
Sí.
again. In establishing water quality goals for the watershed, How do you account for non-point sources of solution?
It's very difficult to assess this contribution in terms of water quality studies or water quality characterization of water masses. It means rivers, lakes. We can measure what is it's the quantity, but some pollutants are adsorbed in the sediments, and it's difficult to show to measure that. But it's very difficult, and in some cases it's expensive to measure the organic pollutants, and sometimes there is no measurement about that pollutants. Well, we need to use this approach into in two ways. One way, of course, is measure, and we propose treatment through the artificial wetlands or something solution-based in nature, to give a certain level of treatment to the agricultural returns of water. And the other way, to change and push or change the agricultural practices in terms to avoid the use of pesticides. But it's very difficult to face the non-point source of contamination. Thanks.
The last question that we have, really quick, is the volume untreated wastewater discharged into the environment versus the volume of the body of water receiving the untreated water a consideration for the need for treatment? In other words, when is treatment urgent slash necessary?
Yes, of course, it's very important to assess what is the quality of wastewater, and what is the uh, characteristics and capacities, like environmental services that our freshwater ecosystem has. And with this perspective, we can establish goals or limits. First of all, limits, permitted limits for the water quality in discharge of our natural body. And if it is necessary to take in account if our water body have important biodiversity, very important species, we have to strengthen our efforts, our limits, in terms of not don't impact this kind of biodiversity that are our allies. The biodiversity is our ally in terms of what is the status of the system, and human, hey, you are doing bad, you are not doing well practices. Please avoid this or that practice. So it's very important, this approach. Thank you for the question. In terms of analyze the wastewater, but analyze and understand what is our capacity of our natural water body. Thanks.
Thank you, Ignacio. We don't have any more questions.
Okay, I think it's close of to. It's time to close. Sorry, I like
Yeah.
to show.
We have reached the end of the synchronous session of Module 3. We remind you to review the virtual campus where you will find evaluative activities, today's presentation, as well as the recording of the session and bibliographic materials to deepen in the subject. Also, your opinion is very important to us, so we thank you for sharing your feedback on this module through a survey whose link will be sent at the end of the week. The information collected in this survey will allow us to develop a continuous improvement of the modules. It has been an honor for us to facilitate this space, and I would like to thank you on behalf of the German Agency for International Cooperation and ICAP for your valuable participation. Thank you for all your questions, and you can disconnect now.
Thanks so much for your time, your attention, and your questions.